Hey guys, these notes are for day 3 in advanced algebra. They cover graphing trig functions like sine and cosine with amplitude changes. So the first graph we're going to look at is y equals sine theta. And you guys have spent a lot of time looking at sine values and cosine values. For example, if I wanted sine of 30 degrees, I would draw a 30, 60, 90 triangle, fill in the sides, and then take opposite over hypotenuse, and that would give me this value of sine of 30 degrees. Now, we do want decimals for this table, so instead of using right triangles or quadrantal angles that you learned in the previous lesson, I'm going to use a calculator to get those decimal values. So we are going to round to the nearest tenth once we punch it into the calculator. So this is 4 sine theta. Now you're used to when you graph seeing an x and a y, and now you're going to see theta and y basically. Theta replaces x because we take sine of theta. Theta represents an angle. So if you're going to use a calculator, you need to make sure it is in degrees and not radians. And you can just email your teacher if you can't figure out how to switch it. On the screen, it will say either DEG or RAD. DEG is what you would like to have. That is 4 degrees. So if I punch in sine of 0 degrees into a calculator, it is going to tell me that sine of 0 is 0. And sine of 30 is 0.5. Sine of 45 is 0.7. Sine of 60 is 0.9. And sine of 90 is 1. If I punch in sine of 120, it is going to tell me 0.9. So you can see there's a pattern here. Sine of 135 is 0.7, then 0.5, then 0. 210 is negative 0.5. Then we have negative 0.7, negative 0.9, and negative 1. Again, a little bit of a pattern. And I did these for you, obviously, before the notes so that you guys didn't have to watch me punch these into a calculator. But again, if you need help doing that, just email your teacher and we can help you. So if I plot these now, I go to 0 degrees and 0. So that is right here, 0, 0. Then 30 degrees and 0.5. So that is right here. These represent degrees down here on your x-axis. 45. Now 45 is right here between 30 and 60, so be careful. That's 0.7. And then 60 is 0.9 and 90 is 1. So you can see this is definitely more of a curved graph. And as I keep going down, you can see now it looks kind of like a hill right there. Then I drop into the negatives. All right. So you can see it's like a hill and then it goes down into a valley. And it looks like it goes from 0 to 360 degrees. Notice that's what our table did, 0 to 360 degrees. As you know, usually the table doesn't show the entire graph. And this one doesn't either. So I'm going to hop over to Desmos where I've graphed sine. And you can see that no matter how far I go to the right or the left, if I hop on the other side of the y-axis into the negatives, this curve goes on forever in both directions. So what we have graphed on our paper is from 0 to 360. So we've graphed that little chunk right there, okay? Or if you want to look at it, it's that little purple curve. That's all we have graphed right now. However, that's all we have. You can see that sine actually goes on forever. So when we plot this, we need to take that into consideration. I'm going to sketch in this curve. I do have to turn my paper, so I apologize. And then we will draw the missing pieces as well. get this curve as smooth as possible for you. All right, so there is that. Now I did put an arrow on the end to represent that that continues on. And then I need to draw in the back half of my graph here. It does look like this. There's that back half of the curve. I got to turn my paper one more time. Sorry. All right. And again, I put an arrow on that end to show that I know this graph goes on in both directions forever. So we've kind of just graphed a little snippet of sine, and it is cyclic, meaning it repeats. So it does this, and then it starts repeating again, and we'll talk about that in a second. A couple things I want to point out are that this line, or this curve, sorry, bounces between 1 and -1. So I'm going to hop back over to Desmos where I have it graphed. And I'm going to show you that these two lines right here, let me put them in same color. Okay. Those two lines represent kind of the boundaries between the max and the min. So my maximum here is 1 and my minimum is down here at -1. And it will continue to just bounce between 1 and -1. So your maximum height is 1, minimum height is -1. Now, if I look at the line going down the center, so if I split that graph right down the center, I have the equation, or the line with the equation y equals 0. So it's kind of hard to see. If you look at the x-axis, it's black, and then now it's red. And that's because I had it graph the line y equals 0. So that is this line that goes right down the middle. And we're actually going to call that the midline. It doesn't really mention it in your notes, so we're definitely going to have to add that in. But again, that line right down the center here is called the midline, and it's basically, in this case, right on top of the x-axis. So if we look at our graph here, the midline is right there. I'm just going to use a ruler to show you. Cuts the graph in half, and it's basically the x-axis. So it has the equation y equals 0. And again, we'll talk about that more in just a second. So let's consider the graph y equals 2 sine theta. So you're going to notice there's a 2 out front. Now, if I just skip that sentence for a second, look down here at the table. I have the same theta values that I did in the previous table. Now, if I want to get 2 sine theta, I would find sine of theta, which I just did, and then multiply it by 2. In other words, take these values, sine theta, and multiply them all by 2. And that will give us the new table. So that's exactly what I'm going to do. 0, 1, 1.4, 1.8, and 2, 1.8, 1.4, 1, and 0. And then -1, -1.4, -1.8, -2, all right, so you can see that wasn't too challenging. I just took my previous table and multiplied them by 2. Now, we're going to do that for all of these graphs. You're going to take the parent table, and you're just going to look at whatever number is out here in front and multiply these values by that number. So this is the parent table for sine. You can probably remember from transformations that we always go back to that parent table and just modify it by multiplying the x or the y values by something. In this unit, you're always just going to be changing these y values. In the next section, I mean, not this unit, but in the next section or sections coming up, you may change the x values, but for this lesson, you're just going to be changing the y values like we just did. We multiplied the y values by 2. If I plot these, you will see that my graph definitely looks a little bit different. I just put them on the wrong spot. Eesh. So I have 45 is at 1.4 and 60 is at 1.8. Okay, so that was, sorry. And then 90 is at 2, and then 1.8. You can see, and then back down here at 0. My zeros didn't change, but all these points did, and it goes much higher now. Down here, they're going to go much lower. So -1, -1.4, and 0. So as we suspected, much lower down here, higher, and then these would be lower back here if I plotted them. Okay, so I'm going to draw in the curve, and I may have to move my paper. Okay, I got that one point a little off. Let's fix it. And then, again, sorry, I have to turn my paper. Okay, not the best sketch, but it will do the trick here. Okay, so there is the graph of y equals 2 sine theta. You can see it's definitely a rough sketch, but it goes higher and lower. So if I think about it in terms of stretching, I took this pink graph and I stretched it horizontally. So that's what we're going to fill in this sentence with. Consider y equals 2 sine theta and what you know about transformations. The 2 will stretch, and we may want to add in vertically up and down the graph of y equals sine theta by a factor of 2. All right. So again, if we look at our midline, or the line that goes right in the middle, it's still the x-axis that cuts our graph in half. So the equation y equals 0 for the midline. And we will write this in just a second. The last one we have here is we are going to consider y equals negative sine theta. So my number out front here is -1. I had +2. Now I have -1. And we're, again, going to come back and fill in this sentence in a minute. Again, go back to your parent table, and this time I'm going to take sine theta, which are all these values, and multiply by -1. So we know multiplying by -1 just changes the sign. So if I multiply all of these by -1, they're going to become negative, where all of these are going to switch to positives. So if I do that, my table will look like this: 0, -0.5, -0.7, All right. So we have filled those in. Now we will go plot them. I have 0, 0 again, -0.5. 45 is -0.7, -0.9. So you can see if I look at my regular sine, it has the same height now. It's just reflected down here across that x-axis. And I can fill it in back here. And draw that in. Maybe I can do it without changing my paper for you guys. Nope. Lucky for you guys, everything's electronic, so you don't really have to sketch all these curves. You'll get to do them on the computer. All right, so if I was to write in my equations here, this is y equals negative sine theta. My pink one is just regular sine theta, or the parent graph. And then the blue one is y equals 2 sine theta. So let's go ahead and hop back down and finish this sentence. Consider y equals negative sine theta and what you know about transformations. The negative will reflect the graph across. Now think about it. The pink flipped down here, and then the pink down here flipped up there. It reflected it across this axis, which is the x-axis. All right. Now we need to talk about the amplitude of a periodic function. So the amplitude of the graph of a periodic function, and sine is a periodic function, as is cosine, is going to be the absolute value of half the distance between the max and the min value, okay? So let's go back up to my sine graph here. And I don't know if you remember, this is the max that we talked about, and this is going to be the min value. If I think about the distance between those, it's 2, one here and then another one here. So the total distance between the max and the min is 2. And if I put rulers in here, you can see that the max and the min, the difference between the max and the min is 2. Okay, this one goes up to 1 and down to -1. If I cut that in half, 2 divided by 2 is 1, and then take the absolute value of it, which I don't really have to. The half the distance is going to be 1. So the amplitude in this regular sine graph is, is 1. Half the distance between the max and the min. Now, if I look at my blue graph here, there is a max and there is the min. The difference between those two is 4 because it's 2 here and 2 here. So the distance is 4. Cut that in half, you get 2. So half of the distance between the max and the min. Now, we'll talk about the absolute value part in a minute. But for right now, let's just fill this in. If y equals a sine theta, the amplitude is going to be the absolute value of a. Okay, so let's think about this. The amplitude of my blue graph here is 2 because it's half the distance between the max and the min. The amplitude of my pink graph was 1 because it's half the distance between the max and the min. Well, the green graph also has a difference between the max and the min of 2. So cut it in half and it would be 1. The absolute value is going to come in right there on that negative graph. So notice the amplitude of this guy is 2. It matches that number out front. Okay, the amplitude is 2 and it matches that number out front. Well, the amplitude of this green graph is 1. But the number out front is -1. So that's where the absolute value comes in. Basically, it says ignore the sign of whatever number's out front and just take the absolute value of it. So that's why A in our equation here is going to represent the number out front. I take the absolute value of that number and it gives me the amplitude. So If I want to talk about the horizontal distance required for the pattern to repeat on a sine curve, I'm going to hop back over to Desmos here and show you a couple things. We already know this graph goes on forever in both directions. Now, I put some lines in there. You can see that 0 to 360 is where those lines are. So there's one here at 0. I cycle here and I'm at 360. Notice after 360, the pattern starts again and it goes for another 360 degrees, or in other words, from 360 to 720. In other words, this graph travels 360 degrees before it starts repeating. That is what we're going to call the period of a periodic function or sine. So the period of sine is 360 degrees, and you can see another cycle of it is right there from 360 to 720. So the period is the horizontal distance required for the graph of a periodic or cyclic function to complete one full cycle. The period of y equals a sine theta is going to be 360 degrees. And you can see that no matter what graph I have, whether it's 2 sine theta, negative sine theta, or just regular sine theta, all of these will start repeating after they complete 360 degrees. So hopping back over to Desmos, you can see that I have my bars in there to show you one period of the sine graphs, no matter if I put 2 sine or negative sine. So that's all 3 graphs. You can see if I turn off, the green one was the negative sine. It still repeats every 360 degrees. Or if I look at 2 sine theta, no matter how tall or how much I stretch it vertically, it still goes through one full cycle from 0 to 360, and then again 360 to 270, and so on. So even though we're changing the height of these graphs, we're not changing anything horizontally. These all today will have a period of 360 degrees. Now, we talked about the midline earlier and that line that goes in the middle of them. I do want to write that in because it will come up in your homework. The midline is that x-axis, or y equals 0. And that's going to be the midline on all of these graphs. And regular sine as well. All right. Hopping over to cosine, we're going to make this a lot easier now. We don't have to plot all of these values, okay? And in the future, when you do graph sine, you're not going to have to do that either. You're just going to graph these quadrantal values. So 0, 90, 180, 270, and 360. So again, in the future, your sine table is only going to have those. So 0, 1, 0, -1, and 0. Had we only plotted those at the beginning, we wouldn't have known what the curve looked like. So moving on to cosine, you'll see that from here on out, our table is going to just look like this. It's going to be much smaller. So when graphing trig functions, we really only need to plot the maximum and minimum values and the zeros. So we're going to add that in here. Now, where in the world do I get these? Again, at the moment, we've been using a calculator, but these are your quadrantal values. So in the previous lesson, you learned that my quadrantal values are my quadrantal angles, are the angles that are on either my positive x, so 0, positive y, so 90, negative x is 180, and then the negative y-axis is 270, and then back here to 360. I know these have the points 1, 0. This one is 0, 1. This one is -1, 0. And this one down here is 0, -1. Now, We also know that cosine is the x-coordinate at these values, and sine is the y-coordinate at these values. Now, we use, like I said previously, a calculator, but if I wanted to know sine of 0 degrees, I just grab the y-coordinate. So sine of 0 is 0. Sine of 90 is 1, the y-coordinate. Sine of 180 is 0, and sine of 270 is -1. So you can see those values on the front of your notes here. Okay, so sine of, and I'm showing you this because this is how you're going to get your values in the future. This is 0 degrees. Sine is the y-coordinate. You can see sine of 0 is 0. Sine of 90 degrees is 1, and that's because the y-coordinate at 90 is 1. Sine of 180 degrees is right here, is 0. Sine of 180 is 0. So you can see these values can be found from this unit circle. And that's how we're going to find the cosine values. Now, the cosine values are the x values as you go around. So cosine of 0 is 1. I'm going to do this in pink. Cosine of 90 is 0. Cosine of 180 is -1. Cosine of 270 is 0. And cosine of 360 is 1. So remember, cosine is your x-coordinate as you go around, where sine is your y-coordinate. All right, so 0, 1, 90, 0. You can see we're plotting far fewer values now. But now that we know that sine and cosine are curved graphs, we don't have to worry about it. This also goes on forever back this way. So I'm going to plot -90, 0. And now I'm just going to connect them. And bear with me, I've got to turn my paper one more time. Sorry. These are not as challenging to draw, in my opinion, when you're trying to pass through fewer points. Okay. Not the prettiest curve, but it will work. All right, so there is the cosine curve. Again, it's a rough sketch. It's easier to graph, but they don't come out as nice because you don't have all the points to go through. But you get the idea. Looks just like sine. However, it starts at different values. So sine of 0 was always 0, and then it went up and down. So they both look like these curves, but they do have different values at different points. They do still bounce between -1 and 1, so they have the same max and min. They're cyclic, which means they repeat. They also repeat every 360 degrees, so they have the same period, same amplitude, everything. They graph very similarly. Looking at this first graph here, the first example where we change the amplitude, I'm multiplying by 1/2, which means when I go to make my table, I just grab my cosine parent table, which is right here, and I multiply these y values by 1/2. Now, when I multiplied by 2, it stretched it, and I went from an amplitude of 1 to an amplitude of 2. This is going to take this graph and shrink it. So I'm going to go from an amplitude of 1 to an amplitude of 1/2. And I'm saying that already. We should know that to get the amplitude, I just take this number out front, A, take the absolute value of it, which this one was positive, so the absolute value didn't change it. The amplitude is 1/2, and again, just like the other ones, the period is going to be 360. So on all of this lesson's work, the periods will be 360. If I multiply all those table values by 1/2, I get this. And as suspected, my graph is much shorter, I guess you would say. And 0. So allow me to turn my paper. Okay, it's a sketch again. All right, so you can see the blue graph is definitely much more narrow. And if I look, it bounces between a half and -1/2. So a total distance of 1. If I cut that in half, I get 1/2, which is the amplitude. And last here, we're going to look at -2 cosine theta. So not only do I have a 2 that's going to stretch it, the negative should reflect it. So we're kind of doing two things here. Remember, the amplitude can be found from the A value out front. I apply the absolute value and I get 2. And remember, that's half the distance of the graph from min to max. And the period will still be 360, which means I go 360 degrees before I start repeating. If I take my parent table, cosine theta are these values. I'm going to multiply all those by -2 to get my -2 cosine values. -2, 0, 2, 0, and -2. And now I'm going to plot those on the same graph. So 0, -2, 90, 0, 180, +2, 270, 0, and 360, -2. As you can see, this is much taller, but it is also reflected. So remember, the pink graph was my parent graph for cosine, so it's reflected down here. So let me sketch this in for you. All right. So there is -2 cosine theta. It's not as curved as I would like it to be, but it's okay. So y equals -2 cosine theta. This blue one was y equals 1/2 cosine theta. And the pink one is our parent graph, y equals cosine theta. Just to fill in a last couple pieces of information, just because I don't want you to be confused, we know that the midline here is still y equals 0, and here as well. It's the x-axis. And just one last reminder, that's this line right here that goes through the middle of each graph. Okay, so remember, graphing in the future, you're going to have these smaller tables, and these values come from the unit circle. Cosine is your x-coordinate as you go around, and sine is the y-coordinate as you go around. So in the future, when you're graphing sine, like we graphed at the beginning, you don't have to do these big tables. Your tables are going to just have these 5 values. If you guys have any questions on this lesson, please feel free to email either your Algebra 2 teacher or any Algebra 2 or advanced algebra teacher on campus. We should all be able to help you. Good luck on your homework.